All right, so we've looked at proportional tables and proportional equations. Now we're going to start looking at proportional relationships on graphs. So just to recap on graphing, remember when you're given when you're given coordinate points, the first number represents your x, second is your y. So when we go and graph these points, our y-axis is our vertical and our x is horizontal. So x is horizontal, y is vertical. Okay, so 0, 10, we go 0 on the x, and then vertically 10, put our first dot. Next one, 1, 8, so go 1 on our x, up to 8. 2, 6. 3, 4. And then 4, 2. Okay, once again, our x is our first number, y is our second. X is horizontal, y is vertical. Okay, so it says, what do you notice about the graph? Well, if you were to connect these points and draw a straight line, it seems that they keep decreasing by 2 for each one you go over. So I say decrease because as you work from left to right, the graph is going down. Okay, next one. We have a table here. It says some t-shirts cost $8 each. Use the table to answer the questions below. What does X represent? X just represents the number of t-shirts. Oops. And Y is just going to represent the cost. Is there a proportional relationship between X and Y? Well, you just take Y divided by X to see if that's true. 8 divided by 1 equals 8. 16 divided by 2 equals 8. 32 divided by 4 equals 8. 48 divided by 6 equals 8. And if you do it for 40, 24, you'll see that they all equal 8. So then yes, this is a proportional relationship. Okay, and therefore, it's going to follow this type of equation, y equals k times x, where k is going to equal 8. 8 is going to show us what it decreases by for each shirt we buy. So if we were to plot this on this graph here, the first, if you buy one t-shirt, you pay $8. If you buy 2 t-shirts, you pay $16. If you buy 3 t-shirts, you pay $24. 4 t-shirts, $32. 5 t-shirts. Oops, $40. I was off by. And then 6 is 48. So there we've graphed them. A couple things we'll notice about the graph here is one, right? If you buy 0 t-shirts, you don't pay any money. And so it's going to go through this point right here where X and Y are 0. That is called the origin. So that would be where it's 0, 0. Okay. A proportional relationship when graphed will pass through the origin. Also, it increases consistently and will follow a straight line pattern as it's graphed. So, straight line that increases by k. And passes through the origin. Okay, so that's going to be a common factor of proportional relationships. And you might not see that it passes through the origin, but if you draw a straight line connecting them, it should go through that point 0, 0. Okay, so this next one, it just says to match the graphs with the tables. And so this is a little bit tricky. You got to go down to this page right here. And here are the tables, and then we match them to the graphs. So I've already went and done it. So table 1 refers to H. So this one right here. Table 2 refers to table B, which is over here. Table 3 refers to G, which is right here. 4 refers to D, which is right here. 5 refers to A, so that first table up top here. 6 to E. 7 to F. 8 to I. 9 to C. And then 10 to J. Okay, and so how we look to see, or how I look to compare these is simply just look at the points. So for X is 1, Y is 10. Well, if I come down here to H, I see that this point right here is 1, X is 1, Y is 10. Go to the next point, that's 2 and 15. And 2 is 15. So you're just looking at how do the points plot. Okay. So when it says examine the graphs closely, what is the same, what is different about the graphs? If you look at the lines, a number of them are straight lines. There's a couple that look to be straight, but if you follow it, they're not quite straight. And there's a couple that kind of curve. And some that are straight, if you would continue them, they would pass through the origin. Okay, and then here, number 2, it says sort the graphs into 2 categories. If you're choosing, label each one. So for me, I did proportional, non-proportional. So the ones that were proportional are going to be B, C, D, F, I. The ones that are not proportional, A, E, G, H, J. Okay, so these are going to be straight lines and pass through the origin. on proportional. Non-proportional, oops, is going to be, they might look straight or they might even be straight, but they don't pass through the origin. And then also they might also have a curve to them. Okay, here in 3, this would be more for when you're in class. You can discuss these with your partners. Okay, 4 just says trade places. So we're not going to worry about that right now. So the number 6 here, which of the relationships are proportional? I've already shown that up here. So all the ones that are proportional, B, C, D, F, I. And then you can refer to which tables those correspond to. Okay, and then what have you noticed about the graphs of proportional relationships? Do you think this will hold true for all graphs of proportional relationships? So the 2 things that you notice is they are straight lines. And 2, they pass through the origin. So 0.00. And yes, this will hold true for all proportional relationships that are graphed. Okay, so last thing right here, it just says which are not proportional graphs. So which graphs cannot represent a proportional relationship? So remember, they have to be a straight line and they have to pass through the origin. So looking at these, if I was to draw a line to connect them, it's a straight line, passes through the origin. So A is proportional. B, it's a straight line, but it does not pass through the origin. It goes through, when X is 0, it's at 5 on Y. So B would not be proportional. C, if you connect these dots, you get a curve. So it's not a straight line, it can't be proportional. And it doesn't look like it passes through the origin either. All right, and then D, last one. So it is a straight line and it does pass through the origin, so D would also be a proportional relationship.